Hello. So our lesson today is a library of functions. And we're also going to talk about transformations. Don't forget to enter the EQ at the end. All right, library of functions. When you talk about a family of graphs, all the functions of lines, that's family. All the functions of a parabola. And when you're talking about functions, when I talked about lines, that does not include vertical lines because they're not functions. Now, if we were in physical class, it would have been a green sheet, but I've put some notes inside of this particular lesson. So in modules for this video and this homework, there's also notes. And this is going to give you a sheet of the parent function. So you don't have to graph everything. Everything's already graphed for you. So if you can print it out or have a PDF, or you want to do your notes in a Google Doc today, that might be helpful. But there's lots of different ways. I'll let you be creative to figure that out. But it'll help you because you'll see I already have the graphs, and that is what is on the worksheet. So it'll save you a lot of time. So I don't know if you want to cut and paste, or like I said, just open up the worksheet, which is in a PDF. I know some people are able to write on PDFs. So what we're going to be doing, we're going to talk about the different family of functions. So this particular family is called constant functions. You can see it is a horizontal line. And there's, infinite amount of horizontal lines. And we're going to talk about the domain and range and symmetry, even or odd, of all the different functions. So if we're looking at here, because it is a flat line, it's horizontal, we know that the domain is all real numbers. The range is only one y value. So f of x equals b. That can be f of x equals 2 or -5 or 0. So how do I write that in interval notation? This is different because there's only one value. Well, it goes to b, starts at b, and it goes to b, and it includes b. So yes, it's brackets b comma b. So does this have symmetry? Sure. It has even because I can fold it along the y-axis. All right, an identity function is f of x equals x. So the slope here is 1, right? Y-intercept is 0. The domain is all real numbers. And the range is also all real numbers. Okay, and what kind of symmetry? Is it even or odd? Can I fold it along this y and get something on this side that's the same? Nope, not a mirror image. Can I rotate in 180 degrees? Yes, and that is odd. Remember, odd is the same thing as symmetric to respect the origin. Right, absolute value function, you can see the bars. It gives us this nice V shape. Now I know you've covered in Algebra 1, and hopefully you did in Algebra 2. Okay, sorry about that. All right, all round numbers. And then you can see the range, it starts at 0 and then goes up. And you may want to try to do the domain and range yourself. Does it fold over this y? Yes, it has nice symmetry. This is even. Symmetric to the respect of y. Remember, they're the same. All right. Square root functions. Now, I'm not sure if anyone has done these. This is the square root. So the domain, if you can see it, and we've talked about the domain, right? And remember, I said it has to be greater than 0. Positive and equal to 0. So in set notation, we would write that. But in interval notation, it's equal to 0, right? Square root of 0 is 0, and it goes to infinity. The range is similar to that in this way, and you're going up. Symmetry. Well, there's nothing on this quadrant, so not even. There's nothing on the bottom over here, not odd, so this is neither. This is called actually a square function, but we know it as a quadratic. But you can see it has that squared. The graph is a parabola. The domain, it is a type of polynomial. It's all real numbers. And you can see in here, right, there's no fractions, there's no square roots, all real numbers. The range, you can see visually, right? It is equal to 0 up to infinity. So it has that nice symmetry along the y that is even. Right? This a cube function, not to be confused with cube root, cube function. You can see the exponent is to a third power, also a type of polynomial. The domain is all real numbers. The range is also all real numbers, right, as you're going this way and that way. And the symmetry, you can see that has this curve up here and a curve up here. It is odd. Right? This is a cube root function. Okay, so it's kind of a little similar, but it's like on the sideways and flip. Okay. Like a square root is only in the first quadrant. You can see this one is in the first and third, right? This is why a cube root can't be negative and a square root can't. So the domain is all real numbers, and so is the range. And like the Q function, it is also odd. Okay. We should know this is a reciprocal function. Some of you may know it as a rational function. You can see it's a fraction, so we know that the domain cannot equal 0. Now, how do I write that? This is going to be a little different. We've never done this in interval notation before. So I'm saying it can be everything except just one number. So it can go from negative infinity to 0, parentheses. And it can be from 0 to positive infinity. And I need to include those two. It's a union. So both of those. So that is the same thing as the range. Okay. So symmetry, it is odd. Now this one is kind of a crazy function. It's called a floor or greatest integer because you can see the output is only integers. And this is a little bit more complicated to write in interval notation. So the range, I'm actually going to write this in set notation. This is sometimes called, well, this is a type of step function. They have a floor function and a ceiling function. And we're not going to do a lot with them, but I want you to be at least have seen them. So, and been exposed to them. So if you can see here how it's open and closed, and it's actually going to keep going all the way down this way, and it's going to go all the way that way. And it looks like it stops at 1 and stops at 2, but it actually right up into here. It goes 1.99999999999, and then the 2 goes up here. So actually it is all real number. And I said I was going to write it in set, not for the domain is actually easy for in interval notation, but the range is different. The range is, can you see there's a gap in between? Do you see? There's nothing in here in the fractions. It's just integers. -2, -3, 0, 1, 2, 3, 4, 5. So my set is integers. And the letter for integers is Z. And you're like, what? Because from the German word of numbers, Zoll. And you're like, oh, okay, Miss Mendoza. Like I said, I just wanted to expose it to you. And this is a neither. And it's not on because one side is open and the other one's filled. Now they're both filled, it wouldn't be a function. So these are 9 functions. Really, it's the 8 that I care about. This one, again, we're not going to do anything with. All right, so those are our parent functions, and now we're going to graph using transformations. Now you can make a table, but they take a long time. So if you know the parent functions, you can do some movement or transformations. So the first thing I'm going to do is graph a parent function, p of x. So I know this is a quadratic. And if you're looking at your the notes, this is the parent function. So for every function, that's its parent, it's x squared. Now, depending what teacher you had, teachers do different things. Some of them make you graph every transformation. I don't do that. This one I'm going to do too, though. So this tells me I'm going to the right. And this one tells me I'm going to go 3 up. Now I'm going to hold that 2 for later. So I'm going to go 1 to the right and up 3. 1, 2, 3. And you do that for every point. 1, 2, 1, 2, 3, 4. Okay, so you moved everything out, 1 and over. Now, here's a little bit more tricky part. It's this stretch. It stretches everything, multiplies it by 2. So all the y values have to go up 2. So this one you're staying where it is. But this one, it went up 1, but instead it's going to go up 2 because you multiplied it by 2. It's actually going to stretch up 1 more. So this one from here to here, it went 4, but it needs to get multiplied. So that actually will be 4 times 2 is 8. So what happens is it gets skinnier. See? So that on the outside, we call that an A, stretches vertically. So the domain is an interval notation. And then my range, it's from 3 up. Okay. Cube root. Oh, sorry, cube function. All right, so if you look back at your sheet, the parent graph, it's 0, 0, 1, 1, negative 1. And at 2, it would be 8, right? If you cube. And negative 2, it would be negative 8. So it's this kind of skinny, cool shape like that. Okay. All right, so do you remember our transformation? So this is going to go left because it's plus, it's the opposite direction, and this is going to go down. All right, so I'm going to do that one first. So I'm going to have such a hard time with these little dots. 1, 2, 3, 4, and down 5. 1, 2, 3, 4, 5. Now, if you do all of them, right, move that 1, 2, 3, 4. 1, 2, 3, 4, 5. Here, stretch that. Now, this is what this would look. I'm just doing a sketch. And I don't always do those because this is not the final answer. You're like, ugh. But then that negative makes it flipped. You're going to flip it. So you're going to flip all the points. Flip. So this 0, 0, oh, this here, their center, is going to stay the same. But this point and this point, they're going to go flipped here. And this point over here, and it's going to go down. There you are. Okay, moving along. Absolute value function. Okay, parent function looks like a V. 0, 0, 1, 1, 2, 2, 3, 3. Then here, remember it's even, so it has to be the same. And it's reflection. Okay. All right. So this one, I'm going to drop down 6. Then I'm going to deal with the 1/4 afterwards. So 1, 2, 3, 4, 5, 6. You're just like, Miss Mendoza, it doesn't look like you're dropping down. No, it doesn't look like it doesn't. But I know that it still has that slope of 1 and -1. So you could drop all the 6. It would be the same thing. Okay. Now what a 1/4 does is this. So that was just my intermediate one. So it means that every going up, it's only 1/4. So instead of up 1, I'm up 1/4. Now that's the hardest one. So the easier one, what if I put in 4? Well, 1/4 of 4 would be 1. So it'd be here. 1/4 of 8, because 8 goes into it evenly, it'd be 2. So it's rather kind of flat. Really low. Right? There you go. So that's your final answer. This is g of x. This first one, if we're labeling it, is p of x, because that's the parent function. And I'm not going to label the green one because it's just my middle one. All right, last one, square root function. Square root, if you're looking at the parent, 1, 1, 4, 2, 9, 3. Now, what does this negative inside do? It's different. If it was on the outside, out here, it would flip it over the x-axis. But if it's inside the argument, it flips it over the y. So it will be here. This is h of x. This is p of x. Ooh, I forgot my domain and range. So this one, my domain, so you can see that it is going from negative infinity to 0. And the range is 0 to positive infinity. The domain here was all real numbers. And then the range is from -6 up. Yeah. So here is a summary of what they do. Vertical shifts, horizontal shifts. Okay. And then the reflection on the outside and the reflection on the inside. Okay. Get to answer the EQ. All right. Until next time, be safe. Bye.